This is for experiment 1, the resistor color bands. As you can see, I have 5 different resistors. I have minimum 3, right? 3 100 ohm resistors, 3 220 ohm resistors, 3 330 ohm resistors, 3 1 kilo ohm resistors, and also 3 10 kilo ohm resistors. It's okay to have more than 3, but we should have at least 3 resistors for each value to run this experiment. And I have 2 cables here, a pair of cables, and red cable and black cable. So one side of each cable has the banana head. The opposite side of each cable has this kind of connector. So it's the hook. So that's the button. If you press the button, that one, a hook come out. The other one, if you press that, same thing, the hook come out. That just make connection easy. If you use different headers, such as like a needle pin, the needle one, that works as well. And here I have a meter. You don't have to use this particular brand or even this model. Any meter works. And now we are going to measure the resistance. For part 1, we need to measure the resistance for all resistors. And since we need to measure resistance, we need to use one feature of this multimeter. So let's look at here. There are 3 ports, 2 red ports and 1 black port. For this one, the label on the top shows V means voltage, omega resistance. This symbol means the continuity of the circuit, capacitance, the diode. So to use that port, you can do, or you can measure all those things. And to measure current, use that port, A, amps, right, that's current. And for measuring either those stuffs or current, we need to have another cord for measuring ground. In other words, either measuring those or that, we need that. So let's do let's connect the port. We need to follow the color code. So this is the color code, color convention. The red cable connect to the thing that we are measuring. In this case, measure the resistance. So connect that to here. For here, connect to the common ground, the black port. Now we are ready to measure. And currently the knob, this dot points to the off. That's why the meter is off. We need to spin the knob so we can measure resistance, which is that, omega. For the first one, that is for voltage, or V, voltage, and the symbol on the top, that is called tilde. That squiggly symbol means AC voltage. The voltage with a bar on the top, that is DC voltage. Here is millivolt range. That one is for measuring resistance. Here is for measuring the continuity of the circuit. Actually, it's just to confirm the circuit is working. The current continues. That one's for measuring the diode, the continuity of diode, AC current, and the DC current. For this experiment, we just need that. So spin this knob, make sure it points to resistance. Now we are ready to measure. So let's take one resistor, just arbitrarily choose one 100 ohm resistor. Resistance or resistor has no polarity, which means we can connect these to either this side or the other side. They all work. So let's put that here. So the other hook or probe connect to the opposite side of the resistor. And here shows the reading. Before, let me undo it. Before it shows 0, no load, 0L, no load, 0 load, resistance, omega. as soon as I connect the probes to both sides of the resistor, and it shows this resistor has 100.9 ohm. If I swap these two, so put this on that side, put this here, the value is same, 100.9 ohm resistor. So that further confirm there's no polarity. There we go. Okay, we need to write down this number to the first table, table 1A. This is the measured value for the first resistor. So put this number in the correct entry, and then next put this aside, and we need to measure the other one. So connect that to here, this to there. The value is still about 100.8. So write down this number to the table for resistor 2. So disconnect, and then we're gonna measure the third resistor. So this one here, this one there. The third resistor has a value of 98.9 ohm, or 9 or sometimes 8, 98.9 ohm. Write down this number to the table. This is for resistor 3, the measured value. So unplug that, and we continue. We continue measure the next one, 220 ohm. So pick one resistor, and then there. It's 216.7 ohm for the first resistor that we picked. So put this number to the next table, resistor 1. Put that here and then measure the remaining one. That there. This resistor's value is 213.8 ohm. Write down this number into the table and then continue. So the third one, this is 217.4 ohm. Okay, write down this number. And next, let's move to the 330 ohm resistor. So I'm gonna take one over here, put that one there, put this one here. This is 324.9 ohm. Okay, write down this number into the table, and then continue measure the remaining resistors. There. And here, 326.0 ohm. Write down this number into the table, and then the third 330 ohm resistor. There. 324.7 ohm. Okay, good. So write down this number. Next, we move to this 1 kilo ohm resistor. That one, let's take one from here. This one, and there. It is 0.986 kilo ohm, which is very close to 1 kilo ohm, right? So, but we need to write down this number into the table. It is 0.98 or 987 kilo ohm. Put this aside and continue measuring the second 1 kilo ohm resistor. This is 0.991 kilo ohm resistor. Write down that number to the table. And now we need to measure the third 1 kilo ohm resistor. That. is 0.994 kilo ohm resistor. Okay, put that here. We have measured all three 1 kilo ohm resistor. Now let's move to the 10 kilo ohm resistor. So I pick one, maybe here, that one, and there. This is about 9.81 kilo ohm, close to the expected value, which is 10 kilo ohm. We're very, very close. So let's put that here. Make sure write down the number into the table. Second one, put that here. Put this hook there. Is 9.82 kilo ohm. Yeah, so write down that number into the table. And now let's measure the last one there. So put that here. Put this one there. Now we get this resistor's value, 9.81 kilo ohm. And now we have measured all these resistors and their values. So this is for part one. This is part one. We should complete filling the tables, at least the measured values parts. And then next, we are running the second part of this experiment. Next, we need to do following. Pick one resistor from each value, just one. So let's say I put that here, pick one, put that there. Pick one of this one, put that here. Mix them. We're gonna mix them. One over here, one over there, and one over here. Don't worry about that, just mix them, shuffle them. Okay, just shuffle that. I can put those apart. Make sure, put them together. You don't want to mix all of them together. Otherwise, you have to measure all of them together. So let me make more space here. And I'll put these here. And put this aside. Okay, so now I have these 5 resistors. They are together. They're together. Let's shuffle them. Let's shuffle them. We don't want to know which one is for what, and we don't want to read the color code or color bands in this case. That's the rule of this game. We're gonna do the following. Right? We take one of each value, one resistor for each value, put them together, mix them together, and we know there are total of 5 resistors. Now we are at step 8C. Don't figure out each resistor values through the color bands. However, we are gonna measure them. So let's just arbitrarily choose one, such as I choose that one. Measure its value. And let's try to figure out this color code, color band. There. But this one is 324.8 ohm. 324.8 is close to 330. So what's the color band color for 330? So first, this is the first resistor we picked. That one. Write down the number into that table and let's figure out its value. Now, once we figure that out, write down the answer into the table and then pick another one. I don't know its value, but we're gonna measure it. There, here. This one is 98.8 ohm. For all this resistor, it's close to 100 ohm, right? 100 ohm. So for 100 ohm, what should be the correct color code and the color bands colors? So let's figure those out and then write down the correct answer in the table. Make sure write down this number to that measured value for second resistor. This is the second resistor we chose or we picked. Randomly choose another one, maybe here, that one. I just arbitrarily choose one, and then let's measure its value. This is 0.987 kilo ohm, which is a 1 kilo ohm resistor. So write down this number into the table 2. This is for the third resistor's measured value. So, and that should be 1 kilo ohm. So what should be the color band's colors for 1 kilo ohm? Make sure write down the answer. And let's do next one. Randomly pick one. Eeny, meeny, miny, mo, maybe that one. And then let's measure it. Here, this one. 9.81 kilo ohm. So close to 10 kilo ohm. This should be a 10 kilo ohm resistor. Write down the number. This is our fourth resistor. Its value is 9.81 in my case. For yours, should be different. And then let's put the correct color code for this 10 kilo ohm resistor. Don't look at that. And next, let's measure the last one. It's 216.7 ohm, and we know the expected value should be 220 ohm resistor. And based on that, first write down this number into the table, the entry, and then let's estimate or let's figure out the color band's colors. Write down those answers in the table. That's the end of the experiment. And make sure once you complete table 2, compare those color bands with the color band shown here. So this is experiment 1.